We're going to go ahead and take a look at the graph of the tangent function. The graph of your tangent function, well, tangent you know is y over x. So on your unit circle, if you go y divided by x at 0 degrees, you get 0. At 45 degrees, you go your y coordinate divided by your x coordinate. You get 1 because they're both the same. At 60 degrees, you go ahead and take your y divided by x, and you get root 3. Which is approximately this. And then you could also do the negative versions of that. At negative 45, you're at negative 1. At negative 60 degrees, you're at negative root 3, and so on. Now, when you connect all those, you get this basic shape. And it repeats, and it repeats, and goes on forever. The blue is the tangent graph. The green here is not really part of the tangent graph, but they're vertical asymptotes. Those are lines that your graph gets close to but never really touches. Because as you get closer and closer to 90, your y coordinate gets closer to 1, while your x coordinate gets really close to 0. And 1 divided by something really close to 0 ends up being a really big number. So the closer you get here, the faster this goes up, and it gets really close to this vertical line but never really touches. For the most part, you're going to just have to memorize the basic shape of your tangent graph. The period of your tangent graph is how far you have to go horizontally before it starts to repeat, and that's from between your two asymptotes, from negative 90 to positive 90. So your period is pi, or if you're dealing with degrees, it's 180 degrees. Now, we're going to start out here with not trying to graph our secant. We know the secant is the reciprocal of cosine. So what we have down here in the dotted red is our cosine. So we have our cosine graph in dotted red here. Now we know secant is the reciprocal of that. So we need to try to graph this. So all we're going to do is we're going to take a look at the cosine values and then just take the reciprocal. Now, we'll start off with taking our cosine value here, which is at a height of 1. The reciprocal of 1 is 1. Now, let's move over here to 60 degrees. The reciprocal of 60 degrees, well, at 60 degrees, your cosine's a half. The reciprocal of 60, you know, is 2. Now, over here, we're going to be at the height of, say, 1/3. Well, the reciprocal of 1/3 then is 3. And we can do the same thing over here. Over here at negative 60 degrees, we're at a height of 1/2. The reciprocal of that is 2. At some point over here, we're going to be at a height of 1/3. The reciprocal of that is 3. And then we could go ahead and draw that in. Well, we can also do the reciprocal functions over here. Here, the reciprocal of -1 is -1. Here, you'd be at -1/2. The reciprocal of -1/2 is -2. And you'd have -1/2 here. The reciprocal of that's -2, and so on. Well, if you keep doing that, you end up getting this shape. Oops, wrong thing. There we go. And so the blue is your secant graph. It's kind of a horseshoe going up here. Once again, we have these vertical asymptotes that your graph gets really close to, but doesn't actually touch. And another reason why you have a vertical asymptote here, you know it's the reciprocal of cosine. Well, here your cosine 0. The reciprocal of 0 would be 1/0, and you know you can't divide by 0. This is your secant graph. The period of your secant graph is 360, or 2 pi, because from negative 90 all the way to positive 270 is one complete period. Once you go past your 270 here, it starts to repeat. It's a horseshoe up again. We also have your secant graph. Your secant graph, you know, is the reciprocal sine. So we have the, in red here, the sine graph. Then once again, you'd want to do your reciprocals. Reciprocal of 1 is 1. Reciprocal of a half is 2. Reciprocal of a half is 2. Reciprocal of negative 1/2 is negative 2. Reciprocal of your height of negative 1 is negative 1. Reciprocal here is of negative 1/2 is negative 2. So when you go ahead and look at this, you end up getting the same basic shape that we had on the previous slide. However, it is just shifted a little bit. Nope, just a second here. Okay, I did see I had a mistake here. So our axes, I had these labeled drawn here at the bottom. It's 0 over here, 180 here. So 90 degrees is right here, and 360 degrees is over here. This is your basic cosecant graph. And you'll notice it's the same as what you had for your secant. However, it's just your secant graph slid over a little bit. And that's the way sine and cosine are. They're the same as each other, just one slid over a little bit more. So therefore, our period is still 2 pi or 360 degrees. Now, let's go ahead and compare these. So let's go ahead and graph these. We're going to graph our basic sine function. We're going to graph 3 times the sine of our function. We're also then, before we graph, we're going to go zoom. And we're going to go to number 7 here, which is trig. Here's your basic sine curve going up to a height of 1. Now here's your second one. And you realize that here, for the second one, that's the one with the 3 in front. Well, how far up does it really go? It goes up to a height of 3. How far down does it go? It goes to a height of 3. So we would say over here, for this particular problem, we would have a vertical stretch of 3 because it was 3 times higher than our original function. We would say it would have an amplitude of 3 because it goes 3 above and 3 below that horizontal line. Your horizontal lines here goes 3 units above, 3 units below. We'll now go ahead and graph the other one here. And so we'll graph this still in the same window. Here's your initial one going to a height of 1. But now the next one comes in, you'll see it only goes up half as far. So really, this number in front of your sine function tells you how far above and below you're going to go of that horizontal line. So it's a half for your vertical stretch because it's only half as tall. Amplitude then is a half. Let's go ahead and see what happens when we put a number in front of your x instead of in front of the whole function. So we'll graph our sine and the sine of 3x. Here's our original function. You'll notice it doesn't go any farther up or down, but it does repeat more often. In other words, the period's not nearly as strong. Originally, you go from your axes all the way out to 360 to get to your period. But here you notice you go up, down, up. There's one period, up, down, up, one period, up, down, up, one period. So you have a 3 periods where you would normally have 1. So we'd have a horizontal stretch then of 1/3 because we have 3 times many. So 1/3 of your normal period, you would then end up getting your period to be 2/3 of a pi. Instead of being your 2 pi, it's now 1/3 of that, so it's 2 pi over 3. Let's see what happens when we put a half in front of our x. So now we graph it. There's 2 complete periods. We put a half in front, and it's making it twice as wide. So in other words, this number in front of x affects the horizontal stretch. In this case, it's twice as wide, so that means our period then, instead of being 2 pi, would be 4 pi. So the number in front causes a vertical stretch, and the absolute value of the number in front is your amplitude. You can also find your amplitude from a graph by going max minus min divided by 2. Your b, the number in front of x, causes a horizontal stretch by a factor of 2 pi over b or 360 over b, depending upon if you're dealing with degrees or radians. So let's go ahead and find our amplitude here. Amplitude is max minus min divided by 2. We're topping out at 8, bottoming out at -4. So we'll plug those in. Then we end up getting an amplitude of 6. Our period is how far you have to go before it starts to repeat. Here, you're starting at a height of 2 going up. Where else do you start at a height of 2 and go up like that? Well, you have to be all the way over to here, so that's a little bit more than 6. So it's a little bit more than 6 for a period. Our frequency, which is just the reciprocal of your period, so you're going to go 1 divided by 6.2, so you get about 0.16. The equation of your midline, that's the horizontal line that cuts your graph in half. The horizontal line that would cut your graph in half would be about in here, where you end up going 6 above it and 6 below. You can always get that by going your maximum of 8 plus your minimum of -4 divided by 2. And so the equation of your midline is y equals 2, and that's that black line. We need to find the amplitude and the period of each one of these functions. Remember, your amplitude is the absolute value of the number in front. So our amplitude is 1. So in other words, we'll go 1 above and 1 below our axes. Now, our b value is the number in front of your theta. That is 1/3. So therefore, to find your period, you're going to go 2 pi divided by 1/3. But instead of dividing by a fraction, you multiply by the reciprocal, and so you get 6 pi. So you're going to get one complete period right here. And that's not exactly what I wanted, but we'll go with it here. This is one complete period. So what I would do is I would draw my axes. I draw one complete period, going to a height of 1, bottoming out at a height of -1. Then I would come along and I would put in my tick marks. In other words, at the end of one complete period, that's where I would put my 6 pi. Now halfway between my period, full period, I know that would then have to be 3 pi. So I would put the tick marks in after I have drawn in one complete period. So we'll do the same thing over here. Over here, we have our amplitude being 1/3, because that's the number in front. So we'll go 1/3 above, 1/3 below. Our b is the number in front here, which is 1, so we know our period is 2 pi over 1, or just 2 pi. So go ahead and draw in one complete period. So I draw one complete period, then I would come along and I would put my tick marks in at how far up I go, and I would put that as 1/3 because my amplitude is 1/3, and how far down, -1/3. And right here I would put this as 2 pi because that's one complete period, and then this is pi, and then I know it would continue on from there. And so your graph would look like this. So here, for cosine, it still works the same. The number in front tells you your amplitude, so you know you're going to go 2 units above and 2 units below your axes. B is the number in front that tells you your b is 1/4, so you're going to go 2 pi over b. Instead of dividing by a fourth, you multiply by the reciprocal, you get 8 pi. So now go ahead and draw in your cosine period, or complete graph. Remember, cosine always starts at the top. Then we'll go ahead and put in our tick marks. At the end over here, one complete period, I'll mark that as 8 pi, which I have right here. Halfway between, I know that's going to be 4 pi, which I have here. Halfway between here and the middle would have to be a fourth of the way through. That's going to be 2 pi, and similarly here. And then I can mark this as a 2, and this as a -2. So now I want to do that for the next one over here. My amplitude is going to be 3, because that's the number in front, so I know I'll go 3 above and 3 below. My b is a 2, so I know my period then will be a 2 pi over 2, or just a pi. So I have to go pi units horizontal, so we'll go ahead and draw the basic cosine graph, and then we'll go ahead and put in our tick marks. So now that we have our basic cosine graph, you know you're going to want to come along then and mark the top as your 3. Sorry about that, and your bottom as -3. Here's one complete period. You're going to mark that as your period right here, pi. So you'll put pi down. Then halfway between, you know that would have to be half your period of pi over 2. So then it also, you know, it continues on from there in each direction. And so you would get a graph that looks like this. So once again, in graphing your sine and cosine, draw your one complete period and then put the tick marks in afterwards. Remembering that sine starts at the origin, where cosine always starts at the top.